Now that we have taken a close look at classes, let's go ahead and shift our focus over to class members. The three most commonly used class members are fields, methods, and properties. As a matter of fact, you've used all three. Back in Volume 1, you had to use them in everything you did in Hyperion and everything you did in Canon 1, Canon 2, and Canon 3. Now, of course, fields, methods, and properties are not the only class members available for classes, as we talked about in the last video. There's all sorts of different member types, and we'll get into those later. But starting in this video, let's focus closely on the three most commonly used class members. So in this video, we're going to look at fields. Now, in understanding fields, there's three key things that I need you to have a strong grasp of by the end of this video. They are, number one, what is a field? Without understanding what a field is, it kind of makes everything else pointless. Next, we need to understand the syntax. And then finally, we need to understand the modifiers. And when we start discussing the modifiers, this is where things are going to get interesting. A lot of the modifiers that we're going to be talking about, the access modifiers, things such as public, private, etc., are going to be applicable for a lot of the different class member types available within classes. So this is going to be the first time you're going to be exposed to these different access modifiers in any sort of detail. So this lesson is going to become somewhat of a foundation for all of the other class member videos. So keep that in mind. So pay very close attention when we start talking about access modifiers. So this right here, ladies and gentlemen, are the three key things that we need to have a clear understanding of by the end of this video. So let's go ahead and start out with the first thing. What exactly is a field? A field is really nothing more than just a local variable at the class level. Let me draw you a quick picture, because you know I love to draw those pictures. If I created a class called Game Item, and inside this class I created two fields. I created two integer variables, one titled position X and the other one position Y. Now these are not being declared inside of a method. Since they're not being declared in a method, that makes them class level. Since they're class level, they are known as fields or data members. Let's take a look at this from a coding point of view. What would this actually look like? Well, we'd come in here and say class Game Item, and then we would have an open curly brace, and then inside we could say public int position X and public int position Y. Now, of course, the class definition would go on with methods and perhaps other data members as well, and then at the end, finally, we would close the whole thing off. But once again, the declaration of these two variables being at the class level and not inside a method makes them fields or data members. So data members. Notice you hear that word members a lot, meaning a member of a class. So AKA, also known as fields. All right, quite simple. Now, these fields are very important. As we were talking about object-oriented programming in past videos, we said that one of the really cool things about it is the fact that objects contain state and behavior. That's what allows objects to really be set apart from one another. It's the state that they're currently in. And this state is derived from our fields. Let me give you an example. Let's say that we instantiated the Game Item class. This means that we got an object now. And let's say this object is titled Player. Now, this object would obviously have a internal position X and a position Y. Now let's say we instantiated the class again, the game item class, into an enemy. It would have a position X and a position Y. Its own position X and position Y. Remember, we drew this once upon a time on the heap, and we showed you what it looked like. So think back to that video, kind of drawing it on the heap right now if you think about it, because game item would indeed exist on the heap, except you wouldn't see position X and position Y actually sitting over here. That would get into a discussion of static, which we'll cover later. So anyways, so we have now taken the game item class and instantiated it into two objects. And now let's say with player, we set its position X to 55 and its position Y to a value of 6. With the enemy, let's say we set him to 25 and to 105 in Y. Now, each of these objects having their own encapsulated data members, position X and position Y, they have their own state. So the state of these two objects are different because of their data members, their own personal data members. Correct, Logan?
Right. All of the data members or fields altogether represent the state of that instance.
Precisely. So if we had a ton of other fields in here, all of these fields being set would indicate or represent the current state of that particular object.
That's right.
Okay, so now that we have an understanding of what a field, it is nothing more than a local variable at the class level. That's the way I like to define it. Let's now go ahead and move into the syntax of creating a field. So the syntax is really straightforward. It looks like this. We're going to start out, if I can get this piece of paper out of my way, with modifiers. Next, we're going to have type. Next, we're going to have identifier. Next thing we're going to have is going to be an optional initialization. Okay, so here is an initialization line or part of the entire syntax that is optional, and then finally a terminator. All right, now let's see one of these position X, one of these fields that we've drawn out over there actually follow this syntax. So public, that's a modifier. Int, that is a type. Position X, that is an identifier. Now we could of course just put a terminator at this point. This means that the data member position X would not be initialized, but we could also use the optional initialization of equals, and we could assign 55 in it. So this means that our data member would always be initialized with the value of 55 in it when we instantiated the game item class. Of course, we could go in there and change it. That's that's up to us, but it would have the value 55 in it. All right, so this right here is us going in there and actually creating a data member. Now, data members aren't only stuck to things such as integers or strings or whatever. I could, of course, come in here and say that I am going to create a public game item. That is of type player. And terminator. So once again, modifier, type, identifier, and then of course I'm just terminating, or we saw when creating these new types, I could say equals new game item, and then open and closing parentheses. Right, Logan?
Right, because, I mean, that's just another variable type, a reference variable type. So all you're doing there is you're setting up a field that can hold a reference to a game item.
That's right. So, I mean, when it comes down to it, when creating your data members, those data members can hold value types. They can hold reference types. It is whatever you need to store inside that particular data member. That's what you need to grasp here. So that is all a field is a basic variable. It can hold value types, can hold reference types, and that covers the basic syntax of creating a field. Now, we need to look at modifiers. We've seen public. All right? Now there are several other ones that we need to cover. Now at this point, I'm going to slow down. In fact, at this point, you may have noticed that I've been slowing down a little bit here and a little bit there because I'm trying to keep this lesson as clear as possible for our beginners so that nobody gets confused. Because even though it's just simple variables, the concepts that we're presenting, and especially the ones we're about to present, can get confusing. So what we need to talk about now is access modifiers. So let me come over here and jot down. So access modifiers. Well, we know we've got public, and we've seen private. Now there's several others. We've got protected, internal, and protected internal. I'll cover those in just a second. What do these really mean? Well, let's think back to the last video. In the last video, when covering classes, we talked about the access modifiers available to us for root level class creation were public and internal. Well, what did public enable to happen? Well, it enabled any other class within the assembly to see that class, and it also enabled any other external assembly that referenced the assembly in which the public class is defined in to see that class. Okay, that was public. Private just kept us locked such that only classes defined within the, or not, excuse me, not private, internal. Only classes internal to the assembly could see that class. Okay? It's real quick to want to jump on the word private, but you got to be careful because you can't use private at the root level when creating a class. So public and internal. Well, what does this mean when we start talking about class members? Well, this is very easy to get, well, quickly confusing here, and I want to try to avoid that from happening. So let's just do some drawings. So I'm going to come all the way down here so I can just make some stuff up. And I'm probably going to, I'm going to be creative here, Logan, or I'm going to attempt to be creative. I'm going to bring up a couple of sheets of paper that I can use. All right, this will represent my current project, or shall I say my current assembly. Inside my current assembly, we know that basically all you have is a whole bunch of classes. And inside the classes, they have their class members. And with the class members, what are you doing? Well, you're instantiating other classes and utilizing them in some sort of logic. And that is where we get our application from. But if you back away and take a look at the big picture, it is nothing more than a whole bunch of classes, okay? And then one class that gets a kickoff, which is our program class, we kick off inside of the main method, okay? So that's how the whole thing gets started. Well, let's go ahead and take a look from this really far back angle. This class right here is going to be game item. Now, inside of game item, we've defined a position X, a position Y, and I'm going to go ahead and put one more thing in there. I'm going to put health. Let's say that all game items have a health. Does that sound fair, Logan?
Right, because if you have a game item that has, I mean, we already saw players and enemies, and both of those need health so that you can take damage and kill them.
So it makes sense to me.
And both players and enemies derive from game items, so it would make sense to have health on game item.
So let's throw in health. And I'm going to start out by making it public. Okay, so that is the access modifier that I am using for the field health. So I'm going to come over here, and instead of drawing everything out, let's just draw out health only. You cool with that?
Sure. That's what we're focusing on right now, is just health.
That's right. So we know game item is going to contain position X, position Y, other things, as well as some behavior as well, which will be the member methods within game item. But we'll talk about methods in the next video. So here we are with health. Now the question is, where can I utilize health? Where can I access it? That's what these access modifiers are all about. Now we know inside of a class, we're going to have behavior. And the behavior comes in the form of methods. So here are two methods that I'm creating. Let me come back up here to code. And if I just drop down a little bit, and let's see, an example to use, what if I wanted to create a, let's say I'm thinking real quick, we'll just do, we'll stick with private. So we'll do a void, and how about, update. Everybody's seen that, right? So we'll do a void update, and then whatever code's inside of it. You guys got to bear with me. I'm coming up with this graphic idea on the fly. And this is a challenging thing to draw. But remember, like I said, we're all just kind of chilling right now, taking it easy. Having more of a relaxed conversation so that we can all understand how this works. Right, Logan?
Sure.
So here's draw. There we go. This works for me. So there, I've drawn it out in code, and I've drawn a graphical representation. So these boxes here inside of health, or excuse me, inside of the game item class represent our method. So this one's update, and this one down here is draw. Okay? Now, update and draw, inside of these methods, I can access health. So this is where, let me do this. So inside of update, I can access health. What does that mean? That means, right, that's funny. Let me do this, come back down here. That means inside of update, I can say health plus equals 5. I don't, whatever. I'm just making something up, okay? But I can access health without any problem, not necessarily because it's public, but because it is inside the definition of a game item, okay? So anytime I tell you that we can access a particular member because it is inside the defining class, this is what I'm talking about. I can access health because health happens to exist inside, I don't know why I pointed to that one, there we go, inside of class item. Or I can point to all of them. I can access all of these guys, okay? So I'm wanting you to kind of get an idea of what's taking place over here in what I'm drawing out. Now, let us say that we come in here and we have another class. And this other class could represent, who knows, this could represent the whole game. Okay, fair enough. So that's, the whole game is taking place inside here. So inside of its methods, so it's going to have its own data members, and it could have 2, 3, 10, 15 different methods. But inside here, we have created an instantiation of game item because we need a player inside the game. Okay? So let's just say that we've got a player. So here's our player, and I'm just going to draw it as a box. This is representing a variable that is pointing to an instantiation of game item. Now, I'm going to do everything I can to make this as clear as possible to understand. So this is a player. It is an instantiation of game item. It is not the game item class. Now, the question is can I access it? So what does this guy look like right here in code? Well, in creating him, he would have looked like something as follows. Game item, player. And then equals, and then just let's stipulate that I've typed out new game item right there, okay? So now we have a player. Now, player, and that is this box right here, okay, this guy right here, that's player. Now let's say I want to access something inside of him. Let's say I want to access health. So dot health equals, and I want to set a number, right? Well, this ability to access is different than the ability to access that you see back here. Back here it is internal. Okay, so we can just see it, period. Now we're doing it through a reference. We're doing it through an object. So now it's a bit different. Now access modifiers play a heavy role in determining if we can or cannot do what I've just underlined right there. Now, what have I set health to? Well, let's look all the way back up here. So here is health, and health was set as public, right? Since health was set at public, what that means is that any member can access, or not any member, but any method can access health without any problem whatsoever. So from right here, I can do exactly what I have shown. I can say player.health equals 5. It's completely legit. Health has been declared public, meaning anybody can access it. Public goes a step further, though. Public also says that if I was to have an external assembly, so here's another assembly. It's a smaller program, so it's a smaller box. And inside this external assembly, I had a class. And the assembly itself references this assembly. And inside this class, I create a game item. Because the game item is public, okay? Again, in the last video, we talked about having public classes and internal classes. So if I came all the way back up to right here and put the word public right before class, that makes everything work nice and smoothly. So now I have created a player over here, or an enemy, or whatever. That's this little box right here. It can also access health, because health is public. All right? So, but once again, the assembly needs to reference it, and we need to instantiate game item, and then we can use health. That's how we gain access to it. Once you get outside the class definition that health is created in. Make sense so far, Logan?
Because obviously you have to be able to see player and game item before you can see things like health.
That's right, for sure. Okay, so private. How does private change things? Because right now with it public, everybody can see it basically. Well, the moment we come up here and we change public to private, we change the rules. Private, we can still access from any of our methods inside of the defining class. Once again, this is our defining class right here, because that is where we've defined health. Any method inside of it can access the health data member with no problem. And any nested class or any nested type inside this class can also see it. So back up here to this. So health is now private. We can still access health from inside game item without any problem. Now let's see what happens when we step outside of game item. So now we're going to go back to game. So here we are down here with game. And remember, with game, we have created a player. And then we tried with this player to set the health to a value of 5. We can't do this now. We would actually have an error because we have said that the health data member is private to the game item class. It's private. So here we are, a whole nother class where we've instantiated game item. So we now have an instance of it. But all because we have an instance of it doesn't mean we can poke around inside it and gain access to that data member. That data member is private. It's encapsulated and hidden away from us. Right, Logan?
Right. Again, private meaning if you're outside of that class externally, you can't access it anymore. It's private, so you have to be coding inside of the class in order to access it.
And that's where you really have to be careful, because I've seen so many beginners think, well, I've got the class right here. Here's player. It's an instance of the class. Please understand what this means. You're dealing with an object now, an instance of the class. We are outside of the class, and we can only access what's inside of it when it's presented to us in such a way that we can access it, i.e., something set to public. We're allowed to access it. It is as if there were blueprints for creating a VCR or a DVD player. That's more of the times. And we have the DVD player at home. There are certain elements that are private or internal to it that we don't need to be able to actually touch. For instance, blueprint for the DVD player. The DVD player has been created, right? We get it home. There are little switches inside when the DVD tray opens and closes that we don't need to be able to physically touch those. They have been hidden away from us.
There's also a laser inside of it.
Yeah.
You can't get to the laser.
Notice how Logan gets all excited. Ooh, laser. That's right. There is a laser inside of it. And it works. It does stuff and all that good stuff. There's motors inside. All that is private to us. So inside the DVD itself, it can work with it. But external, so this player right here, this is really important to understand. The player can have methods internally, and we've actually drawn that right here. If I can find my pen real quick. Here is an update method that exists inside, that will actually exist inside of player. And you'll notice he can touch health. This is, kind of look at this as being external in a way. This is like us taking our giant finger and pushing the play button on the DVD player. Is that
right.
Pretty clear, Logan?
The mechanics of the laser are internal to the DVD player, meaning that the DVD player, some mechanics or a motor inside of the DVD player might have to physically move the laser in order to seek on the disc.
Mm-hmm.
But outside of the DVD player, you don't want to make it possible for a person to go in and move the laser.
That's right.
Because a person can't move a laser accurately enough to change tracks on a DVD. It has to be done more accurately inside the DVD player. Instead, you're given human-friendly controls on the front of the DVD player that let you step through, play, and pause, and whatever else you need for actual, meaningful play controls.
Exactly. And that's what's going on right here. In this particular case, for whatever reason, the designer decided to make health private because he didn't think that anywhere inside of our game or our assembly here that we needed to be able to instantiate the game item and directly access health. For whatever reason, we wanted health private, which would make sense because you really wouldn't want to do that. You'd want health to be set internally inside the game item itself.
Right. Well, what if game item needs to monitor health and check when it goes negative in order that game item can be killed?
That's right.
If you let someone just arbitrarily set health, they might be able to set it negative or 0 without triggering the death.
That's right.
And now that's kind of broken the functionality of health. As now you have something that should be dead, but it's not dead.
So in this particular case, we have redefined health as being a private data member to the game item class, and because of that, that now becomes a compiler error. It simply will not compile because you cannot do that because of its access level. Okay? So that is private. Private simply means that the only way you're going to be able to get to the particular data member is from any method inside the defining class or any subclass within it, or any nested class. That's the word I was looking for. So from within any nested class or any nested type, we can gain access to it. Okay, so that's private. All right, we're all going to take a deep breath. We're now going to add the next access modifier, which is protected. Introducing you to protected puts Logan and I in a very interesting situation. Inheritance is a concept that is not going to be fully explained until we get into the object-oriented programming section 2. Right now we're in section 1. The idea of section 1 is just to give you a relatively detailed overview of the basics of just dealing with a class and its common class members. And that's it. Well, we know with object-oriented programming, one of the major cornerstones of it is inheritance, which is the ability for us to create a base class that is abstract and then have another class inherit everything that base class has, or some of the things that base class has, and then extend it by adding further stuff to it, further class members. Now, here's the predicament we're in. We're not covering that yet. But for you to understand how protected works, we need to cover it. Wow, it's kind of like a paradox in a way. Darned if you do and you're darned if you don't. All right, so let's think about this. I'm going to go ahead and demonstrate at a very simplistic level, inheritance. Okay? So to do that, let's see, Logan, let us come up here and add another sheet of paper real quick. I know how we'll do this. And then we'll just turn that one off and this one off. All right. So inheritance. We have a game item. Now inside game item, he has position X, position Y, and he now has health. Now let's say from this, because all game items are going to have a position in the world and health, I want to extend the game item class and make it just a little bit more interesting. I want to create an enemy. And the enemy has a position X and a position Y and a health. Why does he have those things? Because he inherited them. Okay? So he already has all of that defined. That's the convenience of inheritance. I don't have to reinvent the wheel. I don't have to retype out the code and all. There's no reason to. So that's already there. So now I can come in here and I can add further functionality and more data members to enemy that is specific to enemy that would not necessarily be on a regular player. Okay, so Logan, we're just making stuff up right now. You got any ideas of anything we can throw in here? How about he has the ability to, we're thinking, guys, to shoot. No, because a player would shoot too. I want to play with health. He can regenerate. Why? Because there's nothing worse than regenerating enemy, right? But your player, he can't regenerate. He has to run around and look for health packets to pick up if he wants to regenerate his health. He's just not going to automatically regenerate. So here we have given our enemy some extended functionality to game item. So he has position X, position Y, and health, and now regenerate. Okay? But he has position X, Y, and health Y. Access modifiers come into play here. Because right now, let's just stipulate that position X, Y, and health are all public. If they're all public, and I come down here and check this out, I now say that I want to create an enemy that's called a spider. And what's he going to be equal to? Everybody knows he's going to be equal to a new enemy. So now I have spider, and I can hit dot, and what I see available to me is going to depend on the access modifiers given to everybody. So let's say everybody was set to public. That means that I could come in here and I could set position X, position Y, I could set health, I could call upon the regenerate behavior just by saying spider.regenerate. All of that is right there in front of me because of access modifiers. But here's the key thing I'm wanting you to see, is what is spider? Spider is an enemy. But look what I've done on this line. I've actually said spider.position X. Where was position X at? Position X came from up here. Oh, that's pretty cool. So obviously spider inherited position X. Now, you're going to get yourself into situations when you start writing more complex code where you're going to have a base class. This is known as a base class because we derive from it. You're going to have times where you're going to have a base class that will have members that you do not want to be accessed by anyone who derives from it, for whatever reason. And right off the bat, you might think, it seems like you'd always want to be able to access it. No! Please understand that. There are going to be times where you will have routines internal to the base item. Routines, that means methods. You're going to have methods that are going to be working with data in there that needs to be kept basically it's exclusive just to the game item class itself. An enemy or anyone else that derives from it doesn't need to be able to touch it, but enemy may have its own functionality that in turn ends up basically causing a trickle down so that back in the game item portion, these things get affected.
Right. The practice of making everything public actually tends to erode at the nice packaging you get from object-oriented programming. It erodes at the idea of having different objects represent different things that you want to do, different distinct things. If everything is all as public, things kind of start to blend together, and you can use an enemy as a game item, and you can use something else as a game item. Everything starts to be used, and the use of the item ends up being defined by when you're using it, as opposed to predefining what it is supposed to do. You would start to use enemies to represent something like a bush or a tree.
Right.
And that, again, it just starts to erode at the idea of clean, contained, encapsulated, object-oriented design.
Precisely. Okay, so real quick, before I jump us back to our discussion with the access modifier, since we're getting a little bit of an idea of what inheritance is, let me just show you what this looks like. You do not have to memorize this now. We all know that for defining game item, it would be something along the lines of class, game item, and then we'd have our class body exist in here. So what does the inheritance line look like? It is class enemy inherits from game item. And then once again, the body inside. So the body. I just wanted you to see this because I'm going to have Logan type this out when we give some examples in a few minutes. This line right here, this is how we would represent this scenario where enemy is being derived from the game item. Logan, it looked like there was something you wanted to add to that?
No.
Okay, good enough.
That's so cool.
All right, so now we know we're talking about inheritance. So we're looking at a derived class, and inside that derived class, the members from the base class, do we have access to them? Yes or no? Well, we see that if they're public, the answer is yes. Now let's go ahead and switch our attention back over to here and continue with our quick discussion of protected. So with protected, what that allows us to do is to derive from a class. So we've got a game item. Now let's pretend that we derive an enemy from game item. Now this enemy, it's not like he can stand on his own, right? The game item is part of him. That's the base class. It's the class that we've extended to come up with this new class, enemy. So the question is, does he have access? Does his methods have access to things such as data members in its parent class, if you will? Okay? And it becomes all a part of the access modifiers. Public, yes. Protected? All right. If it's private, the answer is no. Okay? Plain and simple. Meaning that if we come back up here, whoa, that's enough to scare somebody. In this particular situation, if position X and position Y, if these guys were set to private, down here inside of enemy, I could not do this. This would become illegal if position X and position Y were private to the game item class. Okay? That makes this a no-no. They would need to be public, or they would need to be protected. Because think of it like this. If they're private, that means that nobody outside of the class can access those data members. Okay? The only people that can access the data members that are private is the methods inside the class or any of the nested classes inside the class. That's the only place where we can gain access to it. Private, it's cut off. Well, what if I needed to define something like, let's use health as our example. I wanted health to be not seen to anyone else. that is outside of game item. But enemy needs to see health. So it's like I need to set health to private so nobody can see it. But at the same time, enemy has to see it, so private cuts enemy off too. That's not good. That is where I could use protected. If I make health protected in this particular case, then what could happen? Or let's go ahead and even go back to the position X example since I've got that drawn out. If I make position X right here protected, then I can gain access to him inside of enemy. Okay, inside of enemy. What's going on right here, Logan? Are we inside of enemy?
Yeah, we're doing... Oh, no. Yeah, well, we're inside of enemy by the regenerate.
With the regenerate? But my code right here, this line.
Oh, if you've instantiated enemy
it
into a spider, then accessing it outside of... No, you're completely outside of both game item and it.
Very good. That's all right. Now we've got Logan acting like a student too. Sweet. This is going to get fun. Actually, it's not, ladies and gentlemen. That just proves the point of how easy it is to quickly get this all turned around in your head. By setting position X as protected, I can. That's why I just outlined this box. I can use it inside of enemy, but outside of this class, I cannot. So remember, the code that we have here, this code would exist like in a game class or something, right? Could I use it? No, because position X is protected. That means I can't touch it, but enemy can. Okay, Logan, is that pretty clear? I want to make sure that I'm as clear as I possibly can on what protected means.
Right, well, it all, like you had said at the beginning of discussing the three, public, private, and protected. When you got into inheriting, if it was private, then it was going to be private to the base only. If it was public, then the derived classes could see it, but also everyone outside of it could see it, and that would be undesirable.
Meaning that we could see it in here.
So how do we make something...
And here.
Right. But so how would we go about making something that is private to base and derived?
That's right.
So it's like related private.
That's right.
But still private to the outside world. And then and that exists, the word for it is protected. So that way if we stay inside the lineage of game item, we can always see protected members.
That's right.
If we're outside of the lineage of game item, then we can no longer see it or access it.
So if we were coding inside of regenerate here, and I said POSX equals and then something, that's legit. That's completely fine because it's protected. I just see POSX like, well, it's position X because I inherited it. It's just part of me. But down here, this line where I have actually created an instance of the enemy, this line probably exists over in the game class. I cannot access position X because position X is protected. It can only be utilized inside our defining class or nested classes or any class that inherits from it. So, of course, I can turn around and I can instantiate, or excuse me, not instantiate, but I can inherit from it in a class called player. So the player class is derived from game item. Inside here, I could have a method that also talks directly to position X and sets some value. Completely fine. So any class that inherits from the base class can access the protected members inside. Okay? Pretty clear, Logan?
Yeah, again, just deciding on, it all comes down to deciding where do you want to be able to see this field from.
That's right. Now, to make this a little bit more interesting, yes, we can do that here. Let's come back over here to this example. We have set up game item where, let's just say health is being defined as, health is protected, okay? With using the protected keyword, and game item is still public, in my external assembly, I can make a class that derives from, or that is a pathetic looking arrow. So this class also derives from game item for whatever reason. And even though it's in an external assembly, since that external assembly is referencing the assembly in which the protected data member has been defined in, I can inherit the class, and I can access it.
You can kind of trace that out too, because if you're looking at it from this assembly that you're drawing in now, if you look back at the other assembly, if GameItem as a class is public, you can see the GameItem class. That means that if you can see the GameItem class, you can inherit from it.
That's
so
correct.
Back now in the assembly B on the right, that means you could inherit from GameItem. If you inherit from GameItem, you can see any protected member, or public, or anything that's higher than protected. But again, you can see protected members if you inherit.
That's right.
And you can inherit, which means you can see health. And that's how
right.
you can trace it out and find out why exactly you can see protected in an entirely separate assembly.
That's right. But once again, this situation down here, so again, we are stipulating that health is protected. So player.health, health now being protected, this is still a compiler error because we're now outside of the game item. Let's say player was a class that inherited from game item, and then we instantiated player and we stored a reference to it in a variable called player. Okay? We can't say player.health because we're external to it now.
Right, we're coding outside of the player, which means that we can't see it. We're now in some area of code that is not descending from game item.
That is not in the game item class or the player class itself. We're now elsewhere. That's right. So we can't access it directly. So once again, this is a no-no. Okay, so that is protected. Again, just to read off the definition, the member is accessible only by methods in the defining type, any nested type, or one of its derived types without regard to assembly. That's Microsoft's definition for it. Okay? So that's protected. Now let's move on. Internal. Internal is quite convenient. Let's go back to public. What did public give us? Public gave us the ability to access that data member from within any class inside the assembly, or any external class, or any external assembly that was referencing the assembly in which the data member was being defined in. So public just let everybody see it, okay, as long as, of course, the class could be seen itself. All right. Now, what if we wanted to provide access to a data member, or let's just say a class member? Okay. What if we wanted to provide access to it to any method inside of one assembly? So quickly you might say, oh, that's public. But you do not want access from any external assemblies. So now it's like, ooh, it's kind of like it needs to be private but public. Well, this puts us in a situation where we would use internal. Internal is basically public, except we've cut off the ability for any external assembly to see it. Okay? Anything you want to add to that, Logan?
It's kind of like calling it, you want to call it assembly private in a sense, meaning in the same light that something that is private to a class can still be seen throughout the class.
Assembly specific public.
Yeah, exactly. Something that is internal to assembly can be seen throughout the assembly, but can't be seen in other assemblies.
That's right. So any method inside of assembly, which means that if we were to make health internal, then this line right here becomes completely valid. So player.health, no problem, as long as this, that H-E-L-T-H, yeah, there we go. As long as this player exists inside assembly A, then that works fine. Okay? So any method can access an internal data member. All right, so that brings us to our last one. And this is where things get really interesting. What if we wanted kind of a mixture between internal and protected? Meaning, what if I wanted any class inside of assembly A, any method in assembly A, to be able to access a data member, but for some reason outside of that assembly, in another assembly, such as assembly B, I don't want just any old method to be able to access it, but how about any class that derives from the class in which we define the data member? I want this derived class to be able to access it. but now we're in an external assembly. And this is where we get protected internal. Whew. Again, it is really a mixture of internal and protected. Internal in regards to any method inside the defining assembly, inside the assembly in which it was defined. So in this case, it was inside assembly A where we created game item. So any method in any class can see it, as long as, of course, they can see the game item class, which we have said that they can because it's public. External, meaning in any other assembly, the only way we can gain access to, and this again stipulated it's health we're still talking about, the only way we could gain access to health is to derive a new class from the game item class, and that's what we're doing right here. We're deriving a new class, and since we're deriving a new class, boy, that is an awful arrow. Since we're deriving a new class, we now have access to health thanks to the protected modifier in the two modifiers that we're using here. Okay? Logan, is there something you want to add to that?
Another way you could look at it is, let's say it was internal just for reasons of being public inside assembly A.
Mm-hmm.
But you wanted to maintain the ability to create hierarchies of classes in assembly A, and you were happily using that member in all of the descendant classes all in assembly A. Now, let's say you move over to assembly B, and because it's internal, you can no longer see it. And you, if you derived from that game item class, you would simply be missing health if health had been defined as internal.
Okay, right.
Well, let's say now in assembly B we want to make some new versions of game items, but we do want to have access to health. We don't want to make it public, but we want to be able to access it in any derived class. Then we can add protected onto the internal health member.
That's right.
And now over in assembly B we can happily keep deriving from it and using it.
Precisely.
It's like it turns into protected if you're looking at it from assembly B. It's otherwise...
Yeah, it's internal if you're in the assembly in which it is created or defined. And if we're in an external assembly, it's as if it was just protected. It's only through inheritance.
That's right.
Very cool, very cool. So, wow, that are the access modifiers that you're going to be using on a lot of different class members inside of classes. Now, what I'd like for us to do, Logan, is jump over to Visual Studio and see if we can walk through these and give them some actual examples where they can see the compiler going, I don't think so, and saying no, or compiling without a problem. So let's go ahead and jump over to Visual Studio real quick.
All right, bring up Visual Studio, and I'm going to start a console application so that we can try some of these cases out.
All right, now we've been picking on game item. So let's go ahead and start with game item real quick.
All right, I'm going to jump down below the class program so I can make class game item. All right.
Okay. Now, inside of game item, let's we won't worry about position X, position Y. Let's keep this as simple as possible. Let's just do, all right, how about this? I've got an idea for what would be good to have public and private. How about name and health? Because let's say if we instantiate a game item into a player, we can give it a name, like Bob. And if we instantiated an enemy from game item, we could give them a name like King Aragon or King Spider or whatever. You see what I'm getting at.
King Spider, I like
that. So King Spider. So let's go ahead, and that will be the two data members, the two fields that we want to create inside of game item. So we're going to do a string, and let's just start out without doing public or private. Let's just do string.
All right, so we've got a string for name, and then we're going to have, let's say, an integer for health.
Now, you'll notice back over here on the whiteboard that if we jump back up to syntax, because this becomes important now. Wow, we've drawn all sorts of stuff. Actually, I think we can go ahead and hide that for now. The very first thing in syntax was modifiers, but modifiers was optional. You don't have to put them in there. Well, what does that mean happens to accessibility for that particular class member? Well, if we jump back over here, what happens is it automatically becomes private. Logan, let's demonstrate that.
If we jump over to the class view for this project, we should be able to bring up our namespace, which now has game item in it. And if we look at game item, I can bring up the object browser by doing browse definition. And inside of that, here we have health and name. And if I click on either of these, we have private int health and private string name. So that means that private is the default modifier for something where you don't explicitly specify a modifier yourself.
Precisely. So now let's say that we want, go ahead and set them to, let's set them both to public.
Okay. So a public string name and a public int health.
Okay, good. Now, let's go ahead and jump back up into our program class inside of our main method. Because as I was going through all of these different access modifiers, the one thing I kept saying was that basically to access it, you can access it from any method. So we're in a method right now. In the end, that's where you access stuff, from inside of methods. So we're inside the main method. The first thing we need to do is go ahead and create, let's say, a player.
Okay. Let's make a new game item called player. And let's also, let's initialize them to a new game item.
Okay. Now, let's go ahead and set his name to Bob.
All right. So we access that Bob field access the Bob field through player, which we do with player dot name.
And you'll notice with IntelliSense that we've had both health and name show up there.
And we'll set that to Bob.
Okay. Now let's turn around on the next line and set the health to 100.
All right.
Now here's what I was talking about earlier. As Logan goes through and he hits dot, notice how we have external access, if you want to think of it that way, to name and to health. Why do I say external? Because we're not coding inside of game item. If we were working on methods inside of game item, it's like we're working internal to the class itself. Because those methods, that's behavior that belongs to game item. Out here, we're not working inside of game item. That's why we're external to the class right now. We're actually in the program class. So accessibility, this is where the access modifiers can really quickly wreck our day, right? If we try to set something but we're not allowed to set it, then we can have all sorts of problems. But in this particular case, Logan has gone in and set both of these fields to be public. Because of that, you'll notice that IntelliSense said, hey, do you want to set the name or do you want to set the health? Let me help you out. And then Logan took advantage of IntelliSense and filled it all in. Not a problem. If Logan goes ahead and builds the solution now by hitting F6, there's no errors whatsoever. Matter of fact, if you look at the very bottom, you'll see build succeeded. All right, very good. So now, let's say, as from a design point of view, I don't want my health to be public. Because, Logan, let's pretend, well, real world. I don't want to give my health to anyone who just comes up and says, hey, if somebody came up to me and said, hey, what's your name? And I'm going to say Jason, right? They say, hey, what's your health? I don't really know how I'm going to respond to that. It's not really any of their business. I might just say, I'm feeling pretty good today. Yeah, but it's private, so I'm not going to give them my real health. You see what I'm saying? Same thing goes on here. In the game item, I don't want to make the health available for anybody and everybody to access. Because here, you're back in the main method right here, setting health to 100. You have no business setting the health right here. Okay? So let's go ahead and change it from public to private. That means we need to worry about setting our health internal to game item, which makes a lot more sense to me. But we've also just created a problem. When Logan builds now, bink, look at this. Health has been underlined with blue. Let's bring our attention down to the error down here in the error list, which tells us that GameItem.health is inaccessible due to its protection level. That's right, due to its protection level. It is protected. You cannot access it from outside of the class or any nested classes inside this class because it is private. So how can we set the health now? Well, I just said anything internal to game item can access the private field health. So let's do that, Logan. Let's pretend we had a reset health method. And resets health, if you ever called upon it, his job was to reset the health back to 100.
Okay. So we can make a method called reset health. And inside of reset health, we set the health field to 100.
So now let's go ahead and comment out where we've accessed or attempted to access health through the player. There we go. And now let's try to build. All right, check this out. This is actually fantastic. We have no errors down here. The build did succeed. Right now, all we're getting is a simple warning saying that is assigned, but its value is never used. Well, that's pretty much true. We never used its value.
Right, we also don't have a complete program. This is just the start of a program.
Well, if I wanted to, watch this. Let's create another method for me inside a game item called display health.
Okay.
Oh, yeah, this is going to be good. This is going to be a lot of fun, guys. Well, what is that display with an E? Are you trying to signal for someone to help?
Sure, why not?
Okay, so display health, and we want that to do a console.write line. Yeah, you're thinking the way I'm thinking. Excellent. And we can access it directly because we are working inside the game item class, okay? So accessing it directly, but check this out. What I'd like for us to do back here, Logan, is let's go ahead and try to display the health from the player.
So if we make a call to display health...
So player.display health.
I'll just retype that. Player.display...
Notice it's not even showing up in IntelliSense.
Health. So what happens?
Go ahead and run it. Boom. Display health is inaccessible due to its protection level. Now, even though we're focusing on fields in this video, what did I say a few minutes ago when we first started talking about access modifiers? I said that these access modifiers are going to apply to pretty much all or most all class members. All right? Well, what has Logan created? He's created 2 method members. Okay, so these are class members. They're methods. So in these particular cases, he did not put the word public at the beginning of either of them. Since he didn't, just like when working with fields, by default, they are what? Private. So for display health to be seen out here, Logan will need to make display health public.
So if I do that, if I put public, or set public for display health, now if we try to build, everything builds just fine here.
All errors go away. As a matter of fact, if you do a read line right after that, we can just demonstrate that it does indeed work. So we want to get the health, so let's execute. And health is currently set to 0. Now, ladies and gentlemen, go ahead and hit enter. Why is it set to 0? Let's think about this for a second. All because we have set up behavior to set health to a value of 100. Have we ever called upon reset health to set the value of health to 100? No, we've not called upon the behavior. We've only defined it. Okay? Very, very important thing to grasp right here. Because of that, the way that the Common Language Runtime works is when the class is created, and then when we instantiate the class, so now we have the player object, all of our fields are initialized to 0. Our string name is initialized to null because there's nothing in there. Health is at 0, and it just printed out 0. That's exactly what we wanted to see. So if you wanted to, let's say we're going to initialize it by default to 50. You're always going to start the game off kind of sick. Now let's run it. Okay, now we get 50 because when player is instantiated, player automatically gets a health of 50. So when we turn around and player's name was Bob, and then we turned around and we said display Bob's health is set to 50 because when the player was actually created, it was set to 50. Okay? Now, if we wanted to, we could have something call upon reset health to reset the health to 100. But at this point, reset health is private to game item. So something inside of game item would have to call upon this functionality for it to work. We could not call upon it externally because we do not have access to it. Okay, so that was just a little bit of extra playing, Logan, to just kind of really drive home the whole public and private and being able to access from within or not within. But let's go ahead and turn our attention back over to following these access modifiers. So we've looked at public, we've looked at private. Next thing is protected is what we had covered there. So let's truly set up an inheritance situation. How cool would that be? We're going to now set up let's go ahead and set up an enemy that derives from the game item class.
Okay. Well, I could simply go into the code right after a game item, make a class called enemy that derives from game item.
So class enemy inherits from game item. All right. So from inside of here, what do we have access for? Well, first of all, we need a reason to even have this class around. So it needs to be able to do everything that's available in game item and perhaps something else. So the example I gave back over on the whiteboard is all enemies can regenerate. So let's go ahead and define a regenerate method.
So it could do void regenerate. And now we have a regenerate method, and you want to just increment health inside of it?
Yeah, health plus plus sounds great. All right, beautiful. Now, can we see health? So now we're about to start getting into all sorts of interesting things. Health is currently defined as being a private data member to class item. Well, now we're in a different class, and we don't have access to health because health has been marked as private to game item. So right now, if we try to build, we're going to have a problem. So Logan just built, look at that. Right away, health just got underlined down here in regenerate. And if we come down here and read our error from the error list window, we get game item.health is inaccessible due to its protection level. Well, now we can come up here just for demonstration purposes, Logan, and let's go ahead and set this to public.
All right.
Okay. Now, let's build real quick. Error goes away. Beautiful. But we've introduced a problem. Let's go all the way back up here and take these two slash marks out. And let's cheat. Add 3 more zeros. We're going to make a player called Bob, and we're going to give him lots and lots of health. So here we are accessing health, but by design we didn't want this to have, this to actually be valid. We don't want this health to be accessed externally.
But it is good to point out the fact that something that's public is accessible to descendants, because in a sense it's almost like a different form of access here, because we're not directly inside of game item, but we're not entirely outside of game item either.
Right.
We're in a descendant of game item.
Correct. And we're going to don't let that freak anybody out. We're going to start talking a lot more about that in inheritance. But Logan is absolutely correct. Because of this right now, go ahead and hit, as a matter of fact, let me take a peek. What's going to happen? When we're going to instantiate a new game item as a player. So here we are a player. We set his name to Bob, and then we kind of cheat and set his health up to 100,000. We display the health. So we know when the player is instantiated, he gets 50 for health. Go ahead and run it. Wow, we've managed to successfully cheat. He's got 100,000 health points or whatever. All right, go ahead and hit enter for me. Thank you, sir. So what happens when you end up in a situation where you need a derived class to be able to access a data member from above, from the class it's deriving from, but you do not want anybody external to be able to access it? Protect it. So let's go ahead and come back down here, Logan, and set our health to be protected.
Okay. So we could set protected health, or protected int health.
And just by changing that, let's go ahead and build. And look who gets highlighted all the way back up here. Again, let's come down here. Game item.health is inaccessible due to its protection level. Out here, do we see any problems down below? Nope, nobody's highlighted. We don't even have 2 errors down at the bottom. So Logan, once again, let's go ahead and comment that out. Build again for me, sir. Hoo-hoo! We can no longer access health outside of game item or enemy, but we can access health inside a game item, and we can access health inside of enemy. Very cool. And that is what protected is going to give us. Now, internal and protected internal. Well, internal is just, did you want to add something?
No,
okay.
I'm fine.
Okay. It looked like you were about to jump all over something. Internal is doing what? It's just going to set it to act as public, meaning just as a very quick demonstration, Logan, if you don't mind, set that to internal. And go ahead and build real quick, and it'll build just fine. Now let's scroll back up and uncomment that. Now, because it's internal, remember, that means it's just like it's public, so it can be seen in any method inside the assembly. So go ahead and build. No errors, so that works just fine as well. If we had an external class, he would not be able to access health because he cannot access an internal class member inside a different assembly. Okay, so let's go ahead and comment that back out. And then the final thing is simply, if we want it to, and we can go ahead and show this. If you want to go ahead and set it to protected internal.
Yeah, protected is, the spelling. There we go. Protected internal int health.
Okay, so in this particular case, we've got both the advantages of protected and internal. Internal means every single method inside this assembly in every class can access health now, as long as, of course, they can get to game item. So let's go ahead, and at this point, and game item is simply set to internal, so all is good. So go ahead and build, and no errors. Now let's go ahead and take the comment lines back out, or the comment hashes or slashes. All right, and build again. And once again, we can still access that. So everywhere inside of the assembly can gain access to it. Now, an external assembly can access health only by inheriting from game item. So in an external assembly, if we inherit from game item, we then, thanks to the protected modifier, have the ability to gain access to health. Okay? Anything you want to add to that, Logan?
No, I think that about covers it.
All right, well, let's go ahead and jump back over here. And, wow, man, we've really lit up the old whiteboard tonight. So just a real quick recap. Basically, when you're dealing with public, you're dealing with members that are accessible from pretty much everywhere. Okay? Yes, there's specifics to that, but everywhere. Okay? Good enough. Private, now you are dealing with a data member that can only be accessed from inside the class that was defined, and of course from any nested types as well. And when we start getting into nested types, that gets really interesting, and we'll talk about that a little bit later because it starts getting into things like static, etc. But again, kind of outside the scope of what we're doing at the moment. Protected, when we need to have a member that is private to all of the methods inside of the assembly, with the exception of all methods inside the defining class and any inherited or derived class. So any class that inherits from the defining class, the class that defines that particular member, any class that inherits from that can also see it. Very, very powerful. Internal, it's just like public, except for our scope is locked to the assembly, so nobody external can see. And finally, protected internal, the very cool one that we looked at the very end, allowing us to, well, basically lock accessibility in such a way that it's public to all methods inside of the assembly, and the only way to use it in another assembly is through inheritance. Okay? So that is going to cover all of our access modifiers. Now, there are just a few more modifiers that I want to throw out real quick, and maybe just a quick example or two, and then that will wrap everything up for this very short lesson on fields. Okay, so other modifiers. I bet they welcome the silence right now. All right, so no, we're no longer dealing with access modifiers. Now we're dealing with things like static. Even though we're going to have our own video covering static methods and static fields, I just had to throw it out there real quick because it is indeed a modifier that we can use on a field. And what static is going to do is it's going to make the field part of the types state and not an instantiated or not the object's state. In other words, if I came all the way back up to here and we had one more field that was called num game items. See, that's a really good example, huh, Logan? Num game items, what if that guy's job was to keep track of how many instances we had of the game item class? Well, it wouldn't make sense for that to exist on all of these objects. It wouldn't make any sense at all. So we would make this particular field static, and it would stay with the class. That way, each time we instantiated the class to a new object, we could simply add a new number to this. But the number would stay on game item. It would stay in the class. So you could call it the classes or the types state as opposed to an object's state. Okay? But again, more on that when we get into a video that is specifically for static fields and members. Okay, so static. Next. Oh, this one we can actually give an example of, Logan. We've got read-only. Ah, read-only. Good stuff. Read-only is when you need to create a field that is, it's very similar to a constant. It's read-only in the sense that the data cannot be changed throughout its existence. It can only be set. Here's the key thing. Here's what makes a read-only field different than a constant. It can only be set during the declaration/initialization. So right then, or during the constructor. So when the class's constructor is called, when we instantiate a class. Now that is enough to make someone go, huh? That's because we haven't gone over constructors yet. We're going to take a look at constructors when we get into object-oriented programming too. But it is important to understand that when, you know what we can do? Let's come over here and we can bring up our little special board where we take a look into the future. That's right. This board allows us to look at concepts that we haven't yet talked about. When we instantiate a class, what we're basically doing right here is we're calling on the constructor. That is a method that's going to a special method that exists inside the class. And even though we haven't been creating constructors, oh, they're there. That's right. When your code is compiled, the constructor is added in if you've not put one there. So when you call upon the constructor to create your class, that constructor gives you, the programmer, the ability to go in there and initialize certain states when you actually instantiate the object. Well, one of the things that we can do in the constructor, again, it's just a regular method. It's just a special method that always gets called when the object is created. What we can do is go in there and we can set read-only fields at that point. So read-only fields can be set in two places. We can set them when we declare and initialize them, or we can set them through a constructor. After which, you can no longer change the value because it's read-only. Logan, let's go ahead real quick and jump back over into here. And let's see. Hang on. Let me think. Ladies and gentlemen, thinking. How about inside game item, let's create a gender.
Okay. Let's see.
Because it really, just to throw this out to our listeners, it really makes sense for gender to be read-only. Because in this particular game, you cannot change your gender during gameplay. Okay, so let's go ahead and set it up.
Okay, so if we make a read-only gender, let's use a char so that we can have a like M or F to represent male and female.
Yeah, it's a great idea.
So I'll have read-only char gender. All right.
Okay, and now we need to go ahead and set this. So go ahead and build.
So if we build now, whoops,
okay.
that's build
well, that's
and
build
run,
and executing, and everything runs absolutely fine. So now, let's say we wanted to assign gender. Well, the first question is, where could we assign it at? Well, I've already told you, but right now, if you really weren't paying attention, the first thing you'd need to know is where you can access it from. You'll notice that Logan did not use an access modifier, so by default, our gender field is what? Private. Since it's private, we can only set it inside of game items. So let's go down to reset health, just as a quick example. And up underneath that or before it, it doesn't matter. Go ahead and set gender to equal something.
And set it to female.
Gender is now female. So let's go ahead and hit F6. Okay, look at this. A read-only field cannot be assigned to except in a constructor or a variable initializer. That's right, it's read-only. We cannot do that here. So go ahead and remove that line. Now let's go back up to gender and now say equals and then set it there. So now here we've declared and initialized on the same line, and now if he builds, beautiful. So we just have the one warning about gender being assigned but never used. So if we wanted to, let's use it. Let's go ahead and display the player's gender up top. So, yeah, this will be great. So, dot, and then just gender, but we need to go ahead and put that in a right line.
Right line, yeah.
Yep.
So we'll do a console right line. Right line. Player.gender, and capitalize that.
And now, of course, we're going to have a problem here because, once again, when gender was declared, when it was defined, and it was defined as private because Logan did not put an access modifier in there. Let's prove it with F6. So here we go. Gender is inaccessible due to its protection level, so let's go ahead and make it public now. So we simply put the public access modifier in front of read-only. Now let's build. Beautiful. Now let's execute. And we still have 100,000 health points, and our gender is female. All right, very good. So that is read-only. Again, it can only be set in the declaration initialization phase or in a constructor, a class constructor.
But we have proven that it can, in fact, be accessed. If we simply read the value, then obviously we can do that.
We can read it. We just can't change it because it's now read-only, except for the 2 places that I just specified. All right, fantastic. So let's go ahead and jump back over to the whiteboard real quick and bring our attention back down here to this page. Okay, so read-only, continuing on with modifiers. Next one is going to be volatile. All right, volatile is definitely outside the scope of this class. Volatile is for when you are working with a multi-threaded application and you have multiple threads accessing a single field. We want to make sure that the data that's in that field is the most up-to-date data. And we do this with volatile. Again, if we get into multi-threaded applications at some point through our XNA Xtreme classes, we'll take the time to go back and visit this in detail. All right, from there, we've got, oh, here's one we can demonstrate, Logan. New. You've seen the new keyword used when creating a new instance of a class, but how does new apply to a field? That's interesting. Well, Logan, let's go ahead and demonstrate how we can basically show, what's the word I'm looking for? Not just, it's just redefining, if you will.
Right. It is hiding. It's both hiding and redefining. Yeah. If you want to call it that. Let's take a look at
this one's just easier to show you guys.
Let's pick on enemy for a moment and just say that for some reason we wanted to redefine a health field for enemy. Now, at first you might wonder, why would you want to do that? Because game items already have health. But let's just say for some reason we want to have more accuracy when defining an enemy's health. Let's say we want enemy's health to be a float.
Okay, I like it.
So let's do just that. What would happen if we defined a, let's make this private to match the example above. So we'll have private, float, health. That alone is a valid field declaration.
And just that, before Logan even hits build, is very interesting. You should really be looking at this going, because enemy inherits from game item, and since up here in game item, health is a protected internal field, that means we inherit health down here of type integer. But now here we go, defining our own health.
As a matter of fact, if I comment this line back out for a second and build, you'll notice that if we hover over health, we're looking at the game item.health. So already we can see that this health at this current moment means the health defined in game item. Whereas if I bring this out and put my field back in for the private float health, now if we look at it, we can see that's now a float enemy.health.
Ooh, very nice. And check this out, down in the error list, we don't have an error. The build actually succeeded with no problem. But we can see that enemy.health hides inherited member game item.health. Use the new keyword if hiding was intended. Because obviously we don't want to have a bunch of warnings down here when you're, writing an application and compiling. It's good to just get all warnings out of the way. Of course, errors, because error means it didn't build, period. But you want to get all the warnings worked out, too. So the best thing to do here is to do exactly what they suggest. Use the new keyword. So now we're saying, look, we're making a new variable, a new data member here in enemy called health, and we know that we're basically hiding the other health. So let's go ahead and build that. And since we're now telling the compiler we know what we're doing, notice our warning went away. Okay? And so at that point, our health is indeed, it's still a float if you come down here and take a look. Float enemy.health. Okay? But just no warnings. So that is using new. All right, let's jump back down here. Is there anything else? Actually, Logan, I think that's it. That covers all of our access modifiers. And then coming down here, that covers a quick talk about static, a look at read-only, a quick mention of volatile, a quick look at new, and that wraps up all of our modifiers, which makes me have to jump all the way back up here. And the third thing that we needed to understand was modifiers. So what is a field? Well, we now know what a field is. We now know the syntax. And we've taken a very detailed look at all of the access modifiers. And remember, that's going to be very important because we're not going to go into that amount of detail anymore with other class members because it's the same concept, okay? And then we looked at the additional modifiers as well for fields. So with that pretty much wraps up this very short video covering field class members. So thanks a lot, guys.